Okay, so as I said, I'm Itay from Morgan Stanley, and my co-host is Brett. We are both in the public cloud engineering team at Morgan Stanley. Next slide, please. Okay, so a little bit about our use case. So we, like many other financial organizations, are going to the cloud. And to do that, we have decided to use infrastructure as code with Terraform as our tool of choice here. Now, being part of such an industry as a financial industry, lots of other industries have these concerns as well. We are concerned about security. We must always be compliant with a lot of the strictest security controls. And when you go to the cloud, it's not just one team that does it. It's the whole company. So we have to maintain our level of security for whoever is going to the cloud with us. Next slide, please. Okay, I said security controls. I get those of us that are CISOs or security architects probably know what that means. The rest of us probably don't. We are focused on technology usually. So security controls are from Wikipedia, right? The things you put in place to avoid, detect, counteract, and minimize security risks. If we focus about computers and technology, that's usually around confidentiality, integrity, and availability of our data. Next slide, please. Zooming in further, there are these, very zooming on cloud security controls. These are the rules or the commandments of what you shall and shall not do in the cloud. Like you shall encrypt at rest, right? We always have to encrypt at rest. In transit, we don't use, stars in policies. We tag everything to know the ownership. So we have a bunch of rules. And again, this is just a random example. These rules exist for us for each and every cloud service or each and every cloud technology, for each and every cloud pattern. These are the rules that keep us safe. Now, this is not just our problem. And these misconfigurations, if somebody, let's say, doesn't comply with these rules, they're the top one concern of everyone, right? And there's a quote here from an IDC survey that said that everybody's in the same boat here. We're all concerned. We all weekly see an email or a headline about some bucket that was out there open to the internet, or some role that had stars in it, or a WAF gateway that wasn't patched, right? We've all seen this stuff, and everybody's concerned. So we want to mitigate this concern. Next slide, please. Okay, so, meeting controls, it's great, right? I look in my code, encryption enabled equals true. Awesome, right? It's easy. But yeah, it's not, right? So when it's one person doing the work, it's very easy. You trust yourself. You look over your code. You might have some static analysis tool to look at a linter to see everything is up and up. That's great. And when you further away in the journey, you have a couple applications. Maybe it's one team. You trust your team, or you can train your team. You look over their shoulder if you're co-located or whatever. Easy, right? But a little harder. And then there's more than one team, more than one application. There's in the area of 5. There's a couple teams. Then you say, okay, I'll use code reviews. If there's anything wrong, we'll eyeball it. We'll find it. That's great. And as you scale further, you start introducing all these tools that scan your code to see that everything is up and up, tools that scan your environment when things have been deployed to see that if something is misconfigured or drifted, then you get an alert. But as you scale up and up, the amount of alerts overwhelm you, and the process overwhelms you, and the amount of controls overwhelms you, because you have to code a scan rule for each and every one of these. And at some point, you basically pray that your engineers are doing the right thing, and that we don't want to be there. Next slide, please. Okay, so I said the challenge that we're trying to solve here is, on one hand, it's security, right? Security controls must be met. Not best efforts, not, this is fine, it's a non-prod environment, or this is something nobody's using. We are serious about security. Now, when I talk about security, we prefer prevention. So one of our rules is prevention trumps detection and remediation. So you can have something that detects if something is misconfigured and fixes it, or sends an alert to somebody to fix it. But there's always that window of something that's been misconfigured for a while, and we don't like that window. So the goal is to make sure that things are created properly from the start. And as I said, a part of this is scale, right? I could hire 100 security people and have them code review each and every piece of code, but it won't scale, right? There's so many different tools, so many different cloud services, so many applications, and we can't hold them up. We need to scale, right? And we need to do it fast because we're all going out to the cloud. So this is the challenge we're trying to solve. Next slide, please. Okay, so I'm starting to take a look into our solution, and part of it is around how we architect our environments. And what we're describing here is not, I don't think it's unique to Morgan Stanley. I've seen this a lot in other companies. Basically, we have taken an architecture, a layered approach to the architecture to try to mitigate who does what and when. And I'll describe it now. On the lowest tier, we have the account or the landing zone. And again, we like using this. We have an apartment analogy that we use in Morgan Stanley. I've seen it used around everywhere. You move into the apartment, you get an apartment, right? It's like you're getting a cloud tenant, like a resource group on Azure and an account on AWS. And the things you need there, you have your front doors, you have the floors, the things that you have in the apartment that make sure the apartment plays well with other different apartments in the building. So in our technology world, it's if you're part of an AWS org or an Azure management group, it's networking between these environments. It's the basic security guardrails, logging pipeline, assurance tools, the basic, the copy paste of each and every environment. So if tomorrow I have 1,000 cloud accounts or cloud apartments, they all look the same. That layer is identical all over. Next slide, please. Now, on top of it, and again, moving on with our cloud apartment analogy, when you move into an apartment, you want to buy some stuff, but there's some stuff you expect the apartment to have. If you want to buy a washer dryer, you need water, right? You need rain, you need a power outlet, and some things are even more complicated than that. But usually, when you come to an apartment, there's some fixtures that you expect there. And this is akin to networking in the cloud world, or RBAC roles that you expect to exist in the apartment. Also some other resources that we'll focus on. Basically, this is the tier of service enablement. So I want this cloud environment to be used in service ABC. The basic things that exist in every apartment that uses A and B and C exist in the fixtures. We'll focus about this a little bit further in the upcoming slides. Next slide, please, Brett. And the last, but definitely not least, is the furnishing. You move into an apartment, you have water, you have power outlets, but you need your stuff, right? Your equipment. You go to IKEA, you buy all the stuff, you put in the apartment. Similar analogy to go into the cloud and choosing all the resources that you want. And here you'll find the things that relate to the workload that resides in this apartment, in this account, in this resource group, right? It's the VMs, the EC2s, the S3 buckets, the load balancers, all of the pieces of infrastructure in the cloud that comprise of your application, right? Anything except for your application code, basically. Next slide, please. So I said, right, what goes where? We have a clear cut. It's obviously not clear cut, right? Once an account has been created, that's very easy. But what goes where? Why do we decide that some things are here or a fixture versus a furnishing, right? I can argue that a role that is being used by my application, it's part of my application, but its identity maybe it shouldn't be managed there. So there's definitely lots of rule of thumbs, and I can't say it's never one size fits all, but it's about having an open discussion with the stakeholders to figure out what goes where. Next slide, please. Okay, so it's the same slide as earlier, but now if you see on the left-hand side, there's roles and responsibilities, basically. who owns which layer in the architecture. As I said, some of these constructs are complex. The way this works is that the infrastructure teams, curate and make sure that each and every component in the fixtures layer and in the account layer, that's infrastructure, right? It's managed centrally for us by the infrastructure team. Doesn't mean it gets provisioned by the infrastructure team. It means it gets managed and templated and controlled by the infrastructure team. If tomorrow I want to change the way I do security login, the way I do networking, I want to change from a net gateway to some other construct, that's on the infrastructure side. And the layer of furnishing is obviously part of the application. It has its own life cycle. And if we're talking about Terraform, there's a split of state here, state files, or workspaces. If you use a managed Terraform solution like Terraform Enterprise or Terraform Cloud, there's one state file for the application team and one state file for the infrastructure team that comprises of these two layers. But I won't get ahead of myself. Let's move on to the next slide, please. Okay, so fixtures versus furnishing. What are fixtures? As I said, fixtures are things that, again, these are rules of thumb. Some things might move from here to there. But generally, if you have a resource that changes your security perimeter, like access to the internet or other networking, peering between environments or whatnot, that's a fixture. We don't want to expose that to the application folks. We don't want anybody to shoot themselves in the foot by mistake, right? I'm not saying, application people are, don't know what they're doing. They do, right? But we want to make sure to help them not make a mistake. Also, anything that, as I said earlier, that affects shared infrastructure, DNS, networking, security logging, you name it, right? I would not expect the application engineering folks to be focused on that. They have their own concerns, and a lot of them, right? Obviously, some of these components we also handle over guardrails, and the guardrails are part of our landing zone as well. And in comparison, what are furnishings? Everything else, right? Next slide, please. So some examples, I've said some, but let's dig deeper, right? So in fixtures, you would have VPC, if we're talking about AWS, you have blob storage, like S3 buckets, right? You have identity, you have security logging, and so on and so forth. All these things belong in the fixture. A furnishing, by example, as I said, anything else that might be part of the application, EC2 instances, S3 buckets, SQSQs, Kinesis, Kafkas, whatever your application uses, CloudWatch, log analytics workspaces, all this stuff is part of the application. It's being used by the application team. Okay, so that's an interesting title that we put here, right? So you probably guys are not aware of this, right? But Morgan Stanley has core values. And when I wrote this slide, I didn't even think about the document. Somebody went over the slides with me and spotted this. One of our core values, and we don't have a lot, we have 5, is do the right thing. And this strategy that we're following here in the cloud is around that, right? We want to make sure people are doing the right thing. And it's not about trust, it's about helping people to do the right thing. Because if you help people do the right thing, everybody's happy. The right thing gets done and nobody gets disturbed by doing what they do. Okay, so this is the point where I hand it off to Brett to dive into the technical aspect of the solution.
All right, so when we started looking at this problem, there are a couple different approaches you can take. One of the major ones is the standardized compliance and policy as code approach. You set out your security rules in code and you apply them to your environments as they're being built out. And if anything violates these policies, get stopped. It's proactive, it works well, but it puts a lot of difficulty on building out these policies and confirming they're comprehensive. We have quite a few security guardrails that we've been asked to implement by our security teams. And in order to properly lock down cloud services, we would need to write an enormous amount of code per service. An example for S3 would be we need to make sure bucket encryption is enabled. We need to have logging enabled. We need to analyze the resource policy attached to the bucket and confirm it doesn't have any wildcards in it. And there's many examples and many controls we have to append to every single service. And the biggest one concern for us here is Amazon and other cloud providers are always producing new features. There's new features being released for S3 and other services every day, every week. And we have to make sure that we are preventing abuse of these features. If there's a new feature that we need to have controls around before they're implemented in our environment. If we implement policy as code and Amazon releases a new way to replicate data between buckets, we need to have the policy as code enacted before that feature goes live. And unfortunately, we don't have a direct pipeline into Amazon's development rooms. We don't know what they're doing before the public world does. And we would have to come up with these code patches very quickly on release. Or we'd have to freeze the entire module and prevent anyone from using it until we've got the guardrails in place. This is a difficult solution. Some people are able to make it work, but we decided to look at other alternatives. The option that a second option is that we decided to look at Terraform modules as a fundamental building block. In the apartment analogy, these are maybe prepackaged items that you can buy from IKEA that come with a limited set of features that you can, and ways in which you can assemble them, and a good instruction set that comes with. Terraform modules are very powerful. They are repeatable. They incorporate a lot of logic that HashiCorp has written into the Terraform provider and allow us to enact the creation and maintenance and lifecycle of cloud resources without having to write proactive policies, but instead writing prescriptive policies that tell you what you can do with the module. We can bake in security guardrails. We can install a limited control interface and only allow toggling on and off features that we want, that we have reviewed, we have confirmed are secure, and that our application developers have asked for. There's no sense in turning on features that no one's planning to use, because it increases the possible drift or maintenance that would have to do if the way that module works changes. So by building out from the bottom up these Terraform modules, we're able to build a very modular, a centralized, and a simple way for our application developers to quickly build out applications in the cloud without having to understand in intense detail how the cloud provider works. We have many internal developers that want to deploy apps on the cloud. They aren't familiar with the different cloud service providers, or they might want to deploy their application on multiple ones. By using modules, we can deploy standardized solutions across multiple clouds using a common syntax, HashiCorp Terraform. We're able to bake in our security controls, so our developers don't have to go look at a long list of controls before they're able to do anything in the cloud. And it allows us to have a simple skill set for our security and for our engineers, our infrastructure engineers, who are building out these modules. There's no need to learn other policy as code frameworks like OPA, HashiCorp Sentinel. These are useful and we use them in our environment, but we don't need to rely on them nearly as much as simply writing Terraform code and Terraform modules in a controlled fashion. So here's an example of one of the modules that we've implemented for Amazon SQS queues. This is a fairly simple service. SQS is just a queue message buffer. And by implementing a few controls at the design stage, we can ensure that the entire lifecycle is secure. You can see here that this is basically all of the source code. There's not a lot to it, but by restricting the number of different features we enable in the Terraform base resource, the SQS resource, we're able to control what can be done with this module. We can enforce encryption by including, for example, by default, a KMS master key ID. If that key doesn't exist, the queue isn't encrypted, we're in violation of our policies. So you can see here that we have that baked into the module code, and it has to be passed for the module to be built out. You can see on the right-hand side, we have a few annotations, just comments. These are our internal security control references. So when our security staff is reviewing the code, they can go down a list and say, control 1 exists on line 4, control 2 exists on line 5. and they can be certain that their controls are implemented in our source code and in everything that comes downstream of those modules. Other ways we make these modules secure is by relying heavily on the environment and on the execution context. We make use of sources like AWS data sources or CSP data sources in general to fetch sensitive resources or resources that would lead to misconfiguration if they were misconfigured by the end user. Things like an AWS region, you could pass it in as a string, but what happens if someone passes in the wrong string? It gets created in the wrong region. What happens if someone passes in a string that would break the environment deliberately or through some form of accident, or was just copying and pasting too much? So by pulling this data from our environment, from the execution context, we're able to be certain that it's deployed in the correct fashion. Down at the bottom, you can see where we build out our resource policy for this SQSQ, and we take other sources from the environment. So the organization ID comes from the environment context, and the end user doesn't get to state that, doesn't maybe use one org versus another org, or picks the wrong one off the list, or makes a typo. That can't happen with this kind of system. And finally, if there are any hard codes that we need to make, we can make them in the module code itself. It keeps it simple, standardized, and it's also not accessible to the end user, if in the limited cases where we do have to make that happen. Here's an example of the variables. And variables are very important in this kind of system because they're effectively the control interface to the cloud module that you're building out. This is how our developers interact with the module. This determines everything they can see, and it helps by adding in documentation here. You can see that of the example variables we put in here, everything's got a description, everything's got a type. This helps guide our developers because they can see that in the Terraform registry where they go to browse our catalog of modules. Where there's sane defaults, we put those in place. So again, reducing the curve, reducing the number of difficulty. If a developer can assume that the defaults are sane, they don't have to go look up whatever the default message retention is for an SQSQ if they're not concerned about it. But it gives them the ability to override it if they feel like. And finally, we always want to simplify and streamline our development process as much as possible, give our developers feedback early in the development cycle so they don't have to go through a full merge and pull request and deploy to the environment to discover they're in violation of some obscure rule. Whenever we can, we build in validation rules. You can see in the KMS alias ARN that we have a validation rule that restricts the regex of the KMS key that you can pass in. We have controls in the environment that state you have to use a firm controlled instead of an AWS controlled key. And by using this regex, we can confirm that the alias does not match the AWS KMS alias. And as such, we meet that control in place. And also the advantage is here, if someone passes in an invalid KMS key or forgets to do so, they get an error message right off the bat. And this helps shorten their cycle, be able to get back to implementing their application, not having to work with the cloud service provider directly or go diving through documentation. And finally, this is just an example of our policy. You can see it's fairly straightforward, but it allows us to bake in security controls right into the resource. You can't use any resource created by this module to transmit data outside of our organization. And it limits the VPC endpoints that we can control. So again, these are all matching our security controls in the environment, but because they're baked in at the module level, we don't have to worry about anyone violating them. And we can be certain that as we scale to dozens or hundreds of accounts, they are all built with the same set of security controls that can't be bypassed and can't be altered. So to support this, you have to make sure that it's not possible to go in and design your own Terraform code or run your own AWS or Azure or other cloud service provider commands. You can't build infrastructure outside of the infrastructure's code system where these controls live. So our pipelines, the furnishing pipeline we give to our app devs, restricts developers to only use approved modules from our Terraform private module registry. So we enforce this with Sentinel rules that are built into the Terraform Enterprise pipeline, the IAC pipeline. And some of these rules are fairly straightforward. You can't build a resource directly. You have to use modules. You can't pull modules from a different registry or from your local file system. And these rules are just copy and paste. HashiCorp has an excellent GitHub repository full of the example Sentinel rules. We were able to pull these out and make some minor modifications, and we're all done. Module versioning, because this is part of our interface to our developers, they need to understand what changes we're making to these modules and how big of a change to expect. This is also part of the way we communicate with our security staff. In order to confirm with our security staff what degree of change requires security review to confirm that we're still in accordance with the controls on our environment, we implemented semantic versioning. This is a fairly simple system. It's used widely in open source. You can go check it out at semver.org. And basically it breaks down the degree of change into major, minor, or just a patch change. And the agreement we have with our security staff is anything that changes the control interface or the implementation in the environment requires security changes. So our communication to our internal app devs and to our security teams is any change in the major or minor version results in a security review of the module to ensure the new version is still compliant or is in compliance with new rules that have been put upon them. So little breakdown of Semver for anyone who's still catching up on it. Major is breaking changes. So for an example, for our module, it would be new mandatory parameters. If it would change the control interface, say we implemented the KMS key encryption on that SQS module. It wasn't there before, it's there now, it has to be there. It's a breaking change. Any deletion of parameters or any creation or deletion of child resources. We've recently been looking at service linked roles inside of the AWS cloud. And if we create something like that, it would be a breaking change because it's a change to the environment that happens when you deploy the new module version. Minor changes are things like parameter changes. If it changes the way that you can use it or adding new features from the module registry, from the built-in Terraform module resource, that's a parameter change. It results in a change to the environment. Even if it's optional, it needs to be reviewed. And finally, patch changes are just documentation, making changes to tagging for billing purposes or whatever else. And finally, we come back to Itae's challenge. How do we confirm that no matter how many new app devs we bring onto the cloud, that our security controls are met? And we do so by implementing private modules with security controls built in to enact these controls in a preventative fashion, prescriptive versus prescriptive. I think those mean the same thing. Prescriptive versus detective. We don't want to be scanning our environment, finding issues. We want to prevent these issues happening from before they occur. And this allows us to scale out. These modules are built to be basic in scope, so they can be built upon. We can combine these modules to get together to make patterns and things like that. If someone wants an S3 bucket and an IAM role to read it, we can bake those into a pattern by implementing these modules, and our developer can copy and paste that pattern without having to worry about any implementation steps. And this lets them get back to what they want to do, which is develop their application, not play with the cloud infrastructure. And our security teams are happy with us as a result. Well, thank you very much for attending this. We'll be in the chat afterward if you have any questions for us.
Thank you.